This is Andrea Hendricks, and today's lesson is going to be on applications of systems of linear equations. In these types of problems, your goal is to look for two unknowns, because those are going to represent your two variables, and then information that will allow you to write two equations. And I'm going to work 5 different examples for you to just show you how that process works. The first problem says a basketball team played 66 games, then won 24 more than they lost, and we need to find how many games did they win and how many games did they lose. So there are two unknowns in the problem, that is the number of games won and the number of games lost. And so we can set up a variable to represent those. If you want W to be our wins and L to be our losses. And then the information that will allow us to write two equations is that the total games was 66. So that tells us right there that the wins plus the losses was 66. And they won 24 more than they lost. So that tells us that the wins is 24 more than the losses. And then we can solve this with one of the 3 methods, either graphing, substitution, or elimination. This is set up to use substitution, because one equation is already solved for one of the variables. So we're going to substitute this expression into the first equation to get L plus 24 plus L is equal to 66. Combining like terms, that gives us 2L plus 24 is equal to 66. And then we can subtract 24 from both sides to get 2L is equal to 42. So if 2L is equal to 42, dividing by 2 tells us that L is equal to 21. Now we need to find how many did they win and lose. So that tells us that they lost 21 games. To find out how many they won, we can plug back into one of these two equations. So we can say that W is equal to L plus 24. Or in this case, W is equal to 21 plus 24, which is 45. So we know that the team won 45 games and lost 21 games. Okay. Now, the next example says building A is 200 feet shorter than building B. The total height of the two buildings is 1,530 feet. Find the height of each building. So here again our unknowns are the height of building A and the height of building B. So we can let A represent the height of building A and B represent the height of building B. So we know that building A is 200 feet shorter than building B. So from that expression or statement, we know that A is 200 shorter than B, which would be B minus 200. And the total height, so if we add them together, we will get 1,530. And this one again is set up to use substitution, because A is already isolated in the first equation. So when we replace our A with B minus 200 in the second equation, we would get B minus 200 plus B is equal to 1,530. So combining like terms, we get 2B minus 200 equals 1,530. So we can add 200 to both sides to give us 2B is equal to 1,730. And then dividing by 2 tells us that B is, doing my calculation on my calculator for a minute, so that's B is 865. Now what is A? A is B minus 200, or rather 865 minus 200, which would be 665. So that tells us that the height of building A is 665 feet, and the height of building B is 865 feet. Okay, and we can check the total of those together would be 1,530. Our next example deals with triangles and angles. It says to find the measures of the angles marked x and y, where we're given a right triangle with x and y being the two unknown values. Remember, the right angle is understood to be 90 degrees. And then we're also given this relationship here. These are supplementary angles, that is, the two together form a line. So our unknowns are pretty clear. They are the two angles x and y. The info that we know, one thing we know is that in a triangle, the sum of the three angles is 180 degrees. The other thing is the sum of supplementary angles is 180. So we can make our two equations with those relationships. So the first equation is that x plus y plus 90 is equal to 180. And the other equation is that y plus 2x plus 50 is also equal to 180. So if we get these equations in the same format, we can use the process of elimination or the addition method to solve them. So let's do that. Let's get them both in the form ax plus by equals c. So the first equation we can rewrite, let me just do this in a different color, is x plus y is equal to 90, right, if we subtract off 90 from both sides. The second equation, we could write it as 2x plus y is equal to 130, right, if we subtract 50 from both sides. So if we use these two equations, we can decide to eliminate either x or y. So if we choose to eliminate x, we would need a common number between 2 and 1, which is 2, and we need to have a positive 2 and a negative 2 as coefficients of the x. We already have our positive 2, so we need to multiply the top equation by negative 2. And in so doing, we would get negative 2x minus 2y is equal to negative 180, and the second equation remains the same. And now we add those two equations, so the x terms are eliminated. Negative 2y plus y is negative y. Negative 180 and 130 is negative 50. So if we divide by negative 1, we get y is equal to 50. So if y is 50, we can plug back into either one of our equations. So if we know that x plus y plus 90 is 180, and we know that y is 50, we can find out that this is x plus 140 equals 180, or rather subtracting 140 from both sides gives us x to be 40. So the measure of the angles is x is 40 degrees and y is 50 degrees. Another problem is at a concession stand. 7 hot dogs and 2 hamburgers cost $12.25. 2 hot dogs and 7 hamburgers cost $14.75. Find the cost of 1 hot dog and the cost of 1 hamburger. So our unknowns in this problem are the cost of a hot dog and the cost of a hamburger. So if we let's just let x represent the cost of the hot dog and y represent the cost of the hamburger. The other thing that we know are two relationships. We know that 7 hot dogs and 2 hamburgers cost this. 2 hot dogs and 7 hamburgers cost $14.75. Well, do you remember whenever you buy multiple things, you have to get charged the quantity times the price per item. And so to get the total cost, you're going to add up all those things for each different item that you purchase. So if we buy 7 hamburgers, or 7 hot dogs rather, the cost of that would be 7 times x, and also 2 hamburgers, which is 2 times y, we get a total of $12.25. We buy 2 hot dogs and 7 hamburgers, we get $14.75. So this problem is set up to do elimination. So we can eliminate either the x or the y. This time we'll eliminate the y just to be different. So we need a number that both 7 and 2 go into, which is 14. So we need a positive 14 and a negative 14. So if we multiply the top equation by 7 to get our 14. And the bottom equation by negative 2 to get negative 14, we will get these equations. So we will have 49x plus 14y and 12.25 times 7 is 85.75. Multiplying the second equation through by negative 2 gives us negative 4x minus 14y is equal to 14.75 times negative 2, which is negative 29.50. Now if we add them, 49x and a negative 4x is 45x. The y's are eliminated, and we have 85.75 minus 29.5 is 56.25. So if we divide that by 45, we get that x is 1.25. So that tells us that the cost of one hot dog is $1.25. Now to find the cost of a hamburger, we have to plug that value of x back into one of the two equations. So if we use 7x plus 2y is equal to 12.25, we'd have to say 7 times 1.25 plus 2y is equal to 12.25. So 7 times 1.25 is 8.75 plus 2y is equal to 12.25. And now if we subtract 8.75 from both sides, we get that 2y is equal to 3.50. And then dividing by 2 tells us that y is $1.75. So the cost of one hamburger is $1.75, and the cost of one hot dog is $1.25. And then the last example that I want to do says that there are 481 tickets sold for a basketball game. The activity cardholder's tickets cost $1.75, and the non-cardholder ticket cost $2. The total amount of money collected was $906.50. How many of each kind of ticket were sold? So our unknown is the cost of the activity cardholder's ticket, which is represented by A, we'll say, and the cost of the non-cardholder ticket we'll call N. The things we know are the total tickets sold and the total money collected. And this is kind of like the last problem. If you bought 5 tickets, you would have to pay 5 times the price per ticket. And that's how we're going to get this total money collected, because we know how much each type of ticket cost us. So one equation is that if the total of tickets sold was 481, we know that A plus N is equal to 481. The other thing we know is that each of the activity tickets cost $1.75. So we don't know how many we bought. We bought A of them, but we are charged $1.75 for each one. So we'd have $1.75 times A plus $2 times N is equal to the total collected, which is 906.50. And so we can solve this using elimination. If we multiply the top equation by negative 2, that would allow us to eliminate the n's. So we'd have let me change color so you can see this a little bit better, negative 2a minus 2n, and then 481 times negative 2 is negative 962. The second equation is 1.75a plus 2n is equal to 906.50. So the n's are eliminated when we add, and if we add negative 2 plus $1.75, we get a negative 0.25a is equal to negative 962 plus 906.5 is negative 55.50. 0.5. So if we divide both sides by negative 0.25, we get that A is equal to 222. Now understand that should be a whole number because that represents the number of tickets sold, and you can't sell a partial ticket. Now that we can plug in to find out what N is, so if we know that A plus N was 481, we know that 222 plus N is 481. So we can subtract 222 from 481 to get 259. So this tells us that there were 222 activity cardholder tickets sold, and there were 259 non-cardholder tickets sold. Okay? So if you have any questions on these problems, please contact me. Thank you. Bye-bye.